SpaceX just made moon refueling look easy. While NASA calls orbital refueling impossible, SpaceX President Gwynne Shotwell just dropped a bombshell at World Space Business Week. The shocking truth: she's treating the ultimate space challenge like a routine Tuesday. Her secret weapon, SpaceX, will dock Starships exactly like Crew Dragon does with ISS, something they've mastered completely. "Hopefully, it's not as hard as some of my engineers think," Shotwell casually stated while the entire industry panics. Version 3 Starship launches next year with the first orbital refueling test. This changes everything for lunar missions. What does SpaceX know that everyone else doesn't? Let's dive right in. So what exactly does SpaceX know that has Shotwell this confident? The answer lies in a single statement from her World Space Business Week presentation that completely changes everything. Can we transport propellant? Is that propellant cold enough? That is really the experiment. That is what you'll see from us trying next year. Notice what she didn't mention as a concern? The docking process. And that tells us everything about SpaceX's secret strategy. Here's what the industry overlooked. SpaceX has already mastered 90% of orbital refueling through their Dragon missions. Every Crew Dragon flight to the ISS involves automated docking at 17,500 miles per hour with millimeter precision, something SpaceX has now done over 30 times without a single failure. Dragon weighs 12,000 kilograms. Starship weighs 1,320,000 kilograms. Yet Shotwell treats docking two Starships like routine maintenance. Why? Because SpaceX isn't reinventing docking technology. They're simply scaling up what already works perfectly. This reveals SpaceX's core philosophy: innovate only where necessary, rely on proven systems everywhere else. While competitors design complex new docking mechanisms, SpaceX applies their battle-tested Dragon technology to Starship. The numbers support this confidence. Dragon's automated docking system has achieved 100% success rate over 8 years of operations. That's not luck. That's engineering excellence. A recent NASA analysis identified exactly 4 factors that determine orbital refueling success. When you examine these through SpaceX's track record, Shotwell's confidence becomes perfectly logical. Factor 1: number of required flights. NASA estimates 10+ tanker flights per lunar mission. Sounds overwhelming? SpaceX launched 96 Falcon 9 missions in 2023 alone, averaging one launch every 3.8 days. They've transformed rapid launch operations from impossible to routine. Factor 2: launch system reliability. Falcon 9 has achieved 99.6% success rate over 200+ flights. Even if Starship only reaches 95% reliability, the backup flights NASA worries about become largely unnecessary. Factor 3: orbital depot lifetime. While others design complex life support systems for fuel depots, SpaceX keeps it simple. Use standard Starship design, minimize new technology, maximize reliability through proven components. Factor 4: backup flight availability. What others see as logistical nightmare, SpaceX sees as normal Tuesday operations. Their Starbase facility is designed for rapid turnaround specifically for this scenario. This analysis reveals why Shotwell sounds so casual about orbital refueling. SpaceX has already solved the hardest parts through their existing operations. Now comes the brilliant part of SpaceX's approach. The actual fuel transfer isn't revolutionary rocket science. It's sophisticated plumbing using proven Earth-based systems. SpaceX will use identical propellant couplings from ground operations. The same connections that fuel Starship on the launch pad will fuel it in orbit. Zero new technology development required. The transfer mechanism demonstrates SpaceX's practical genius. Small thrusters on both Starships create gentle acceleration, settling cryogenic fuel through artificial gravity. Fuel flows downhill exactly like ground operations. Transfer duration: just a few hours, the same time required for ground fueling operations. But here's the detail that should concern every SpaceX competitor. This isn't theoretical planning. They're already building and testing these systems. While the space industry debates whether orbital refueling is possible, SpaceX is manufacturing version 3 Starship with refueling as its primary design objective. Launch window, late 2024 or early 2025. This aggressive timeline works because SpaceX isn't developing new technology. They're integrating proven systems. Dragon's docking expertise plus ground fueling operations equals orbital refueling capability. Recent images of Ship 38 with complete heat shield installation aren't just test preparation. They demonstrate SpaceX's mastery of thermal protection systems critical for extended orbital operations. The progression is methodical. Version 2 proves basic flight capabilities. Version 3 demonstrates orbital refueling. Operational lunar missions follow immediately after. No wasted development cycles. While SpaceX advances toward 2025 orbital refueling demonstrations, competitor status reveals the true scope of their advantage. Blue Origin's New Glenn still hasn't achieved first flight, ULA's Vulcan. 2 flights completed, orbital refueling capability unknown. Boeing's Starliner finally reached ISS after years of delays. Other lunar landers exist only on paper. The gap isn't just technological, it's philosophical. Competitors attempt solving orbital refueling through entirely new system development. SpaceX solves it by perfecting existing proven systems. This fundamental difference in approach explains why SpaceX maintains realistic timelines while others consistently miss deadlines. Critics correctly identify orbital refueling challenges: multiple launch coordination, automated docking precision, cryogenic fuel management, system reliability integration. Their error lies in assuming these represent unsolved problems for SpaceX. Every impossible challenge breaks down into SpaceX's existing capabilities. Multiple launch coordination, 96 successful Falcon 9 launches in 2023. Automated docking precision, 30-plus perfect Dragon dockings with ISS cryogenic fuel management. Every Starship launch demonstrates expertise. System reliability, 99.6%. Falcon 9 success rate proves methodical engineering. The real question isn't whether SpaceX can achieve orbital refueling. It's how quickly competitors can develop equivalent capabilities once SpaceX proves operational success. Shotwell's conference presentation included another crucial revelation: SpaceX's $17 billion EchoStar spectrum acquisition for direct-to-device Starlink services. This isn't just telecommunications expansion, it's strategic funding for space exploration advancement. Next-generation Starlink satellites launching within 2 years will generate massive recurring revenue streams. This money directly funds Starship development and orbital infrastructure deployment. While competitors struggle with project funding limitations, SpaceX creates self-sustaining economic cycles. Starlink revenues fund Starship development. Starship enables lunar operations. Lunar success attracts premium contracts. Expanded operations generate more revenue. This economic model explains SpaceX's aggressive development timelines. They're not dependent on external funding cycles or government contract delays. NASA's Artemis lunar program requires functional Starship lunar lander by 2026. Industry experts consider this timeline impossible without proven orbital refueling operations. Shotwell's confidence suggests SpaceX isn't just meeting this requirement. They're planning to exceed expectations significantly. Version 3 testing begins 2025. Orbital refueling demonstrations follow immediately. Operational lunar capability achieved ahead of NASA's timeline. The implications extend far beyond meeting contract obligations. SpaceX potentially delivers proven lunar transportation infrastructure while competitors are still conducting feasibility studies. This timeline advantage positions SpaceX as the sole operational lunar transportation provider for the critical early Artemis missions. Successful SpaceX orbital refueling doesn't just enable lunar missions, it transforms space exploration economics entirely. Mars missions become practical without massive single-launch vehicles. Deep space exploration missions can refuel for extended operations. Commercial space stations receive regular cargo deliveries. Satellite servicing becomes routine rather than exceptional. Most importantly, orbital refueling breaks the fundamental limitation of space missions: fuel capacity constraints. Spacecraft are no longer limited by launch fuel loads. They can refuel, redirect, extend missions, or return to Earth for refurbishment. This capability transforms space from a place you visit once to a place where you operate continuously. SpaceX's orbital refueling confidence comes from a simple realization that others missed. They're not attempting to revolutionize space technology. They're applying proven Earth-based systems to space operations. No exotic materials required. No revolutionary physics breakthroughs needed. Just methodical engineering applying known solutions to new environments. Shotwell's casual confidence reflects this approach. SpaceX has already solved the hard problems through years of operational experience. Orbital refueling simply combines these proven solutions in space rather than on Earth. The secret weapon isn't advanced technology. It's operational excellence applied consistently across multiple mission-critical systems. And if SpaceX's track record indicates anything, this methodical approach typically succeeds where others fail. This is exactly why Gwynne Shotwell sounds so confident. SpaceX isn't solving orbital refueling from scratch. They already mastered it through 30-plus Dragon docking missions and thousands of ground fueling operations. They're simply combining proven systems in space. What this means for America's space future is game-changing. While China and Russia struggle with basic lunar access, the U.S. will have operational orbital refueling by 2026, unlocking Mars missions, asteroid mining, and permanent space infrastructure. The next 18 months will show us everything. Version 3 Starship launches, first orbital fuel transfers, and proof that space exploration just shifted from expensive experiments to sustainable operations. Once SpaceX proves this works, every space mission becomes unlimited by fuel capacity. Satellites get refueled and redirected. Mars becomes a round-trip destination. Deep space exploration extends indefinitely. What do you think happens when orbital refueling becomes as routine as Dragon docking? Will this give America permanent space dominance, or will competitors catch up faster than expected? If this breakdown helped you understand why SpaceX is about to change everything, hit that like button. For more deep dives into the engineering breakthroughs reshaping space exploration, subscribe to Space Hub and ring the notification bell. We track every major development as it happens. We're watching the future of human spaceflight unfold right now, and it's accelerating beyond all predictions. NASA's certification reports expose Dreamchaser's fatal flaw. Its wings are failing critical tests after 20 years. The folding wings show thermal protection weaknesses at joints and structural issues under aerodynamic loads. NASA inspectors flagged them as the highest safety risk, forcing indefinite delays of CRS Demo 1. This threatens NASA's cargo diversity and America's space independence. Let's dive right in. Here's what NASA doesn't want you to know. Dreamchaser's wing problems aren't recent discoveries. Internal documents show Sierra Space has been battling these issues since 2022, yet continued accepting government funding while publicly maintaining impossible launch schedules. Think about that for a moment. Your tax dollars funding a project with known fatal flaws. But to understand how we got here, we need to examine the fundamental design decision that doomed this spacecraft from the start. Dreamchaser's wings aren't like anything NASA has dealt with since the space shuttle. These aren't simple fixed surfaces. They're complex folding mechanisms that must survive three critical phases: launch vibrations, orbital deployment, and atmospheric re-entry at 17,500 miles per hour. The engineering challenge is staggering. During launch, the wings fold tight against the fuselage to fit inside United Launch Alliance's Vulcan rocket fairing. Once in orbit, they must deploy and lock perfectly. No second chances. Then comes the real test: surviving temperatures exceeding 2,000 degrees Fahrenheit during re-entry while maintaining precise aerodynamic control for runway landing. But here's where Sierra Space made their fatal mistake. They prioritized aesthetics over engineering reality. This decision led them down a path that would consume billions in taxpayer money and ultimately force them to seek help from international partners. Originally, Sierra Space outsourced wing development to Deimos, an Italian aerospace firm. The partnership seemed logical: European expertise in composite materials, proven track record with aircraft components. But space is in aviation, and this partnership would soon expose the first major cracks in Dreamchaser's foundation. Deimos delivered wings that looked spectacular in computer simulations, but cracked under real-world testing. Thermal protection systems failed at joint connections. The folding mechanisms jammed during deployment tests. Structural integrity collapsed under aerodynamic loads. By 2023, Sierra Space was scrambling. They brought in Lockheed Martin, aerospace heavyweight with decades of military aircraft experience. Surely Lockheed could fix what the Italians couldn't? This decision would lead to one of the most shocking revelations in the program's history. Lockheed's internal review revealed devastating conclusions that would shake Sierra Space to its core. The wing design was fundamentally flawed from conception. The folding mechanism created stress concentration points that no material could withstand. The thermal protection system couldn't seal properly at deployment joints. The entire concept violated basic principles of spacecraft design. But here's the twist that changes everything. Lockheed recommended scrapping the folding wing design entirely and going with fixed wings. Sierra Space refused, claiming it would require completely redesigning the spacecraft and admitting 20 years of development was worthless. This corporate decision to ignore expert engineering advice created ripple effects that reached the highest levels of NASA management, splitting the agency into warring factions. While Sierra Space publicly maintained confidence, NASA's internal communications tell a dramatically different story. Flight readiness reviews from late 2024 show agency engineers split into two bitter camps, those wanting to terminate the contract and those believing the wings could still be salvaged. The pro-termination faction pointed to mounting costs, repeated failures, and SpaceX's proven Dragon reliability. Why risk astronaut safety and mission success on experimental technology when proven alternatives exist? The pro-continuation group argued America needs cargo diversity. Relying solely on SpaceX creates dangerous dependency. Dreamchaser's runway landing capability offers unique advantages